Well, hello, class, and welcome to a rainy Wednesday edition of Oceanography. I trust everyone is safe and dry and ready for another class. This week, we will be discussing the ocean floor, continuing with it. Last class, we went through plate tectonics and how the ocean floor has subduction zones, has mid-ocean ridges and other ridges, not necessarily in the middle of the ocean where spreading occurs. We also discussed the transform fault. Before we kick off today's lesson, I need to put up the activity associated with this week's lesson. This Wednesday, we already have our assignment and we've already gone over it. So next Wednesday, you have an educational handout due. Now, I just made it an educational handout because in oceanography, you would probably, when we're talking about the ocean floor, I'm not necessarily thinking you're going to be making a presentation in a business setting unless you're working for a mining or mineral company. But making a presentation is a life skill that I would like to help you refine by using science as the topic. So it kind of fits in our class science-wise. And it also gives you an opportunity to work on things that are going to help you beyond science. So I picked an educational handout again, because, that's generally what you'd be looking at in an oceanography or science setting. Everyone is familiar because everyone's in class or had classes. We do have a College of Education. So we may have some prospective teachers, but regardless, throughout your life, you will be making presentations through work, most people, or definitely in college. The educational handout then is a key when you present, to have handouts. I chose 7th grade, not necessarily randomly, but because I don't want you, when you're doing your research or putting together the handout, to go for a PhD level. We just want to cover the basics of the ocean floor. So, say 7th grade, or even an introductory earth science class in 9th grade is about the scope that we would look for. So you're going to 2 pages minimum on the ocean floor. One topic is the Atlantic. The second topic is the Pacific Ocean floor. You're not necessarily limited to 1 page for the Atlantic because you'll probably have images, or at least I hope you have images. So it might take a little more than a page, where the image would take up a portion of the page and the discussion of the floor, Pacific image discussion. So it is a 2-page minimum, but feel free to go over. I don't necessarily want 5 pages or 10 pages. That's not the impetus of this assignment. It's designing a good handout to go along with a presentation. Down the road, you'll be doing a PowerPoint or Prezi, not doing the presentation itself, but designing that portion of a presentation with a different topic to help hone your skills. I do require that you have your references separated in a separate file. So you'll be turning in 2 files. One's going to be your handouts, and they're not like a quiz or an activity. It's informational handout. It's simulating supplemental notes. So it's going to be the details, and then the references. You see here, there is a hyperlink included. I'd like to go to that hyperlink really fast because it's very helpful. I include these hyperlinks in the assignments. This is the best practice tips to make a handout. Now, really, we're only going to focus on the handout portion. We're going to look at the slides down the road. So, you know, the benefits of the handout, obviously, you can cut down on, you know, focus your presentation. Audience have concrete reminders. You can follow along with your handout so you don't forget what to say. The tips, you don't have to worry about preparing in plenty of time. The assignment's due next Wednesday, so you'll turn that in. We're not going to require slides now, so you're going to want to ensure that your handout reflects the presentation. I've already given you a topic. You can put your information in there, include references, which are on the side. So these are nice tips on how to design a handout with your presenting skills. So what we're looking for is a handout, Atlantic, Pacific Ocean, images and details, supplemental notes at least a 7th grade level, but don't go for the gusto and come up with your references from peer-reviewed college PhD level. We're really not interested in that. We're really interested in the topography and composition of the seafloor. That's due next Wednesday. Are there any questions regarding this particular assignment?
What do you mean when you say double-sided? Want us to?
Well, this is also designed for an in-person class where you'd hand it in and then you could use double-sided. It's not limited to that. Being you are submitting it via a file, it's irrelevant.
Okay,
yeah,
thank you.
That's just for like in class, people would turn it in, it's double-sided. Save paper. Any other questions regarding this particular assignment?
So it's PowerPoint.
No, not PowerPoint.
Mm.
This is a handout in a Word file.
Okay, Word. Okay.
Yes, Word. Now, to discuss the Atlantic seafloor and the Pacific seafloor, we're going to have to learn about it. So today's lesson, we will be studying the ocean floor. Just another reminder as I'm downloading this, Monday is a holiday. Monday is a holiday, so we will not be in class Monday. You're not going to have me to nag at you Monday to remind you to get your work done, that means. So this is my last nag of the week, promise. Remember, you have assignments due tonight, and then this is due next week. So we don't have class Monday. So the next time we'll get together is next Wednesday, and that will be the due date for this. So this is my pleading to be a self-starter and get this done so you can, at least over the weekend. So if you have questions, you can email me. I'll be back in the office on Tuesday. Text will be for emergencies only. I'll handle any questions you have regarding this next Tuesday, if you're working on it over the weekend, because I plan on enjoying the holiday myself. So I'm not going to log in and work on things like that. Now, of course, if there's an emergency, you're sick, you need an extension, something bad happens, you can text me that ahead of time for your approval. But, you know, content type questions and stuff, send an email and I'll answer them when I'm back in the office on Tuesday. If you need me to give you a phone call to help walk you through it, that's fine too. Include your phone number in the email. I get to the office around 7:30, 7:15, 7:30, depending on traffic at my daughter's school. So I will call you around 8 on on Tuesday morning if there's questions. So although, we're not together Monday, I'll call you Tuesday morning if there's pressing issues. All right, so we're going to look at the ocean floor. The opening slide right here, you can see this is a relief map showing the features of the seafloor. This is the Atlantic, and you can see right down the middle, there's Iceland, and right down the middle, you have that ocean ridge system. We beat that dead horse last class with the ocean spreading. You also have your transformed faults. You can see how they are perpendicular to the seafloor spreading, and that's because it's not a consistent material that's making up the floor. There's different rocks and different stress factors going on, and then the plates are spreading apart at different speeds, so there's fracture zones. You can see as you move away from this active spread center, the seamounts and guyotes, which are the undersea extinct volcanoes, have been eroded and they're getting smaller. And then you have the abyssal floor here, here, and it's very flat in many areas. That's called the abyssal plains. And the topography are in the abyssal floor are called abyssal hills, generally seamounts and guyotes. Here, just a little point of interest, there's your Bermuda platform. Here is the shelf break. You can see the slope going up. Continental shelf. Notice off the coast of Florida, there's a little channel that has been eroded by the Gulf Stream loop current because the equatorial currents come, they separate, go through the Gulf. Part of it does, part of it moves up the East Coast. They rejoin. We'll learn about that ocean flow when we talk about currents. So you don't have to have it memorized, but when we introduced oceanography our first week, we mentioned the Gulf Stream and loop currents, and you can see it's had quite an influence on the Florida platform. There's the Florida platform. 2/3 of Florida is underwater currently. So here's your continental shelves. They're just granitic, just like the continents. They just happen to have a lower elevation, so they're below sea level at this time. There's your continental slopes. That's a very steep drop off to the basaltic oceanic crust. The basaltic oceanic crust, the ocean basin, has abyssal plains with hills, has the mid-ocean ridge, and then you're on Europe, Africa, you see they have a continental shelf as well. So this is a relief map showing the topography of the Atlantic Ocean. In your assignment that I just discussed, we have an Atlantic and a Pacific. They are very different. And that's why we don't just have a generic ocean floor. The Atlantic is considered a passive margin. Here's your only active plate tectonics with your island arc that we covered, that archipelago. So here's very passive. You have a wide continental shelf. You have a lot of deposition, sediments, a drop off. There's no subduction going on here, no coastal volcanoes, hundreds of miles offshore. It's still relatively shallow. So that is a passive continental margin. The Pacific Ocean, as we know, there's a lot of earthquakes, and the Ring of Fire has volcanoes around it as well. That's an active margin. So when you're doing your handout, one of them is the passive margin. The example is the Atlantic. One of them is an active margin. The example is the Pacific. So you'll see that the setup is different, and that's why you have to have 2 pages or a little more than 2 pages, if, depending on how many images you select. One would be, then they're very distinct. Now, bathymetric studies, that's the study of the ocean floor. you can see in this chart here, and we went over charting a little bit, you have your isobaths. Those are lines that connect equal depth. Here, the isobaths are close together. That means there's a drop off. Here, they're far apart. That means it's pretty flat. So in Florida, the East Coast has that drop off. The West Coast is fairly flat. Let's go back to the relief map just to see. There's that drop off, that channel that's been carved by the Gulf Stream. Look how wide ours is. So that Gulf Stream that's carved that channel leads to, there's the drop off for it. And then it's pretty flat again. And if we're extending this out, it'd be flat, and then you'd have a severe drop off. And you can see a drop off starting right there above the NOAA sign. That drop off would be right here, right where the cursor is. So the bathymetric maps show you the depth, and then from them you can get an idea of the topography. So that's a bathymetric map or a bathymetric chart. They're often called charts when you're looking at oceans. Early bathymetric studies were very rudimentary. They were made with weighted line and measured in fathoms every 6 feet. Modern, we have many different ways to measure now at our disposal. The most common are echo sounders. Echo sounders use sound. We know how fast it travels. So you get the time for the echo to come back, divide it by 2, and then a simple mathematical formula gives you your depth. We don't even have to do the math. The computer on our echo sounder, chart plotter, they're also called, which are amazing if you are a boater. You can go buy a chart plotter. It's a little like screen, it has the GPS on it. So you get your latitude and longitude right on it. It has a chart, a lot smaller scale, but a chart of your area. And it has a little dot for you. And it gives your depth using multi-sound echolocation. So you know your floor topography and where you are on a map by using GPS. They're quite amazing. But echo sounding is how the ocean floor has been charted. Right now, most of our chart plotters are 121 sound. It's not really a beam like light, but they use 121 beams of sound to get a little topography of the ocean floor. They're multi-beam systems. Echo sounding became sophisticated in World War II because in World War II, the Germans invented what was called the U-boat submarine. And they were torpedoing the daylights out of our merchant ships. Most of world trade, and it still happens today, most of world trade is completed via waterways. It's a whole lot cheaper to float freight on water than fly it in the air with jet fuel. So international trade is generally done by freighters. Also, it's a whole lot cheaper to float large objects around the East Coast than it is to truck them. So although trucking is very important, so is floating because the buoyancy, it takes less fuel. German were trying to cripple the American economy to help win their war. It was a good strategy. They were torpedoing our ships, our freighters. So it was really putting a dent in the economy and making the war effort that much more difficult. So in response, we dredged the intracoastal waterways. We're all familiar with the intercoastal waterways here in Florida. It's the bridge you drive over to get to the beach. Our beaches are on barrier islands. Then there's a little lagoon. It's called a lagoon, or the intercoastals today. And then mainland. You drive across that strip of water, you're on the beaches. So the Corps dredged a channel around the entire East Coast and then the Gulf Coast of the United States. Now our shipping was protected. It wasn't out in the open ocean. Then echolocation was used to detect submarine activity. Not because you have a small confined space, you can only enter and exit out of passes. It made it a lot easier to monitor German U-boat. So it really helped with the war effort. So after the war, we have all this new technology and the intracoastal waterway systems. All the dredging spoil islands because they were dumped spoil islands. You go to Dunedin, you got little islands dotting every 100 yards or so. It depends on how often it was dug. Clearwater, you cross Sand Key and all those bridges, and you can see beautiful islands that are just man-made. We have near Fort DeSoto, there's a lot of spoil islands too. So all these spoil islands were also created during World War II. We really changed the intracoastal waterway system, which is now recreation sail clubs sail around the intracoastals, and they're used for shipping still as well because they're protected. And recreational anglers and fishermen use these spoil islands because they provide great habitat. Echo sounders, now you can buy them for a couple $100 and slap them on your boat, and you're good to go. And all that came from this World War II. Another way we actually, now it's very fascinating. When I learned this, I was amazed. Sea level's not level. There's up to a 10-meter difference in water height in the ocean, depending on the seafloor topography on average. Now, of course, storms and waves, so you have to get an average. But let's say you have a seamount. Islamorada has a seamount, beautiful seamount right off the coast of Islamorada. It's a big hump. It's called the humps. Currents come and they go up the hump and then down the hump. When they come up the hump, it brings up nutrients, and that's why the fishing in the Keys is so brilliant, because these humps push this nutrient-rich water up. Sea level follows the topography. So when there's a hump, average sea level goes up over that hump. Just like that upwelling current, the sea level rises a little bit, can be several meters higher. Over trenches or deep cuts, sea level dips to follow that. So sea level mirrors seafloor topography. Now, I never thought that myself, thinking water was flat on top, but it's not. It follows the topography. So we can map very accurately the ocean floor from outer space. The radar and stuff we use that we shine, put down on Earth, that doesn't penetrate to the bottom of the sea to get the bottom. They measure sea level and they can map the topography of the ocean floor. So satellites are used for the ocean floor as well. So the topography of the ocean floor, and this is greatly exaggerated to show, but here's land. So we have mountains here, mountains, flat, Great Plains, small mountains here. This is just showing you the height of land. The ocean floor has topography as well, but on a grander scale. So here's your continental shelf, continental slope. Then you have your shelf break. Granite ends, basaltic begins. There's your ocean ridge. This right here is a seamount. And then here's your shelf break again, continental slope. continental shelf. So this is a cross-section across the Atlantic Ocean. The Atlantic Ocean is a passive margin, except for this Caribbean arc right here. The tectonics occur at the ridges and they're divergent. Typically, you have wide continental shelves, fairly flat. You can have some topography, but fairly flat abysses. That's called an abyssal plain, and an oceanic ridge system. That's generally the topography of the Atlantic. Mount Everest would fit in a deep sea trench, and still you would have kilometers difference. So, you know, our highest features on land are dwarfed by oceanic features. I did say there's two types of crust: continental crust, which are made of granitic rocks. Granite is a less dense, high in quartz rock. Continents are less dense and they sit up higher. Ocean crust is made of basalt and basaltic rocks. Basaltic rocks have more metals in them. They're more dense, they're lower. It's also a thinner crust. So our continental margins are, and we'll see this a list before, but let's pop back and just have a look. Our continental margins are made up of the continental shelf, the continental slope, and then at the bottom of the continental slope, there's generally a buildup of sediments, continental in origin, that have just been swept over the edge by erosion. So continental shelf, continental slope, and a pile of sediments, and that sediment pile is called the continental rise. Then you have your seafloor, your ocean basin, which is the abyss, the abyssal plains with abyssal hills. That the abyssal hills are generally dead volcanoes, seamounts and guyotts, they're called. And then you have the oceanic ridge system. So that's our continental margins, ocean basin.
Professor, how
Yes,
on
David.
that last slide, how far out toward the spreading zone does the continental shelf extend?
Okay, it depends on where you are in the ocean. Some places have wide and some have narrow, but you know, here in your scale in miles, this continental shelf is only about 50 nautical miles wide. It can be up to 200 nautical miles wide in other cases. And the distance here to the ridge is maybe 1,000 nautical miles. So it's quite far from the ridge.
Is that the same as the continental crust, the continental shelf? Is that
The
the same?
continental shelf is the portion of the continent that is currently underwater due to changing sea levels. It is part of the continent, but it's underwater.
And where is the continental crust?
The whole thing is the continental crust.
Oh,
And the part of the land that's currently underwater.
okay. So the actual physical continents can be described as continental crust.
Correct. That just refers to the granitic rock that makes up the continents and the shelves, and they are connected.
Thank you.
You're welcome. So here, this pie chart I'll point this, and this helps with Dave. Yellow is the continental crust. 11% of our continent are currently underwater. So the continental crust makes up 40% of the lithosphere, but only 30% is above sea level at this point. Sea level rises and falls with the ice balance. During a glacial period, sea level, all the continents are exposed. Sea level's low because there's a lot of ice. When the ice melts, sea level rises and parts of the continent are underwater, the low-lying parts. So as we lose our ice caps, this will change. More of the continent will be underwater, but the continental crust is going to be the same amount. So the edge of the crust, the continents are very dynamic because sea level's rising and falling. A lot of factors into that. When you lose ice that's on the water, let's say the northern ice cap sits on the water, there's no land underneath it, the Arctic Ocean's frozen. If that were to melt, sea level would stay the same. If you lose ice that's on land, let's say Greenland's glacier melts, sea level's going to rise. So sea level only changes when ice melts that is on land. The components of the continental margin, we mentioned the shelf and the slope and the rises, which is that pile of sediments. The edge of the shelf is called the shelf break. So another image. This is what it looks like in real life. They exaggerate it so you can see the features here. Your shelf break is the pile of sediments, and it's sitting on oceanic crust. So you have a pile of sediments that have washed off of the shelf. Your shelf can vary, it varies. This particular example is extreme. It's showing you about 210 miles of continental shelf. An active margin may have 100 yards of continental shelf. Then you can be the abyss right next to the land, because active margins are different. Passive margins, you have a lot of sediments, wide continental shelves. Drop off down, that's your slope, shelf break, where the slope ends. There's your shelf break. All this is the abyssal floor. The distance varies. So some areas it's wide. This is a very wide example. In other areas, it's narrow. And that's how a passive continental shelf looks. An active continental shelf, this kind of sums it up for you. Here's your Atlantic margin, passive. See how wide that is? Here's your active margin with plate tectonics. Very narrow, steep drop off, steeper drop off because it drops off right to a trench. Active margins have volcanoes. Passive margins, flat. So passive margins, very flat, very wide shelf, a lot of sediments. Active margins, very narrow shelf, very deep. Active plate tectonics occurring. The Pacific margin is very active. The Atlantic margin, very passive. So when you do your handouts, you can see the difference. It's a stark difference between active, passive. Now they have the same elements. The continental shelf is the continental shelf, the part of the continent that's underwater. So all of our continental crust comes from here, shaded yellow, to here, shaded yellow. Some of it dry, high and dry. Some of it under sea level. But that's all granite. This is your granite. Here's your basalt, the green. Can everyone see the difference between the Atlantic margin and the Pacific margin? This is a nice image that shows you that. The passive margins, we are, look, sediments. There's your continental rise. So there's a lot of deposition, the depositional environments, a lot of thick sediment deposits on passive margins. When you look at active margins, the sediments get swept and pushed under into the mantle and melt. So you don't have your continental rises. You don't get a lot of sediments because they are destroyed at the tectonic boundary. Passive, you get a lot of sediments, and so you have a lot of fossils, fossil records, fossil fuels. These are great places for oil, because remember, oil comes from the ocean. These are not great places for oil because all the sediments are destroyed. These are great places because the sea life, the little critters that die, they're preserved, they're covered, and the oil is cooked out of them, basically. So here's a passive margin, lots of sediments, oceanic ridge, wide continental shelf, pile of sediments, your basaltic occurring. Starting with the continental shelves. This is the history of sea level for the past 250,000 years. So we're in an ice age. We're in a very mild ice age right now because there's ice caps and continental glaciers. The peak of our ice age, A, was about 20,000 years ago. Wisconsin glaciation period, sea level was very low, about 130 meters. Now remember, a meter is a little more than a yard, so we're talking about 400 feet. Sea level rose about 400 feet. The peak of, well, the highest sea level's been was right here, a little higher than we are today over the past 250,000 years. So you can see ice, when you have ice, you have very low sea levels. When ice melts, you have higher sea levels. So point A, right here, that is the climax of the Wisconsin glacial period. We're in an interglacial, which means we still got some ice caps, so we still are technically in an ice age, but most of them have melted. So sea level's high. Here's a 3D image of what we got. There's your abyssal floor. There's your continental slope. There's your shelf break. So your continental crust ends here. Oceanic crust begins here. The part of the continent underwater is called the shelf. And then we have land. This image shows you the same. Submarine canyons, they're not deep. Now, these submarine canyons are drowned rivers. Remember, this used to be the coast right here. The ocean was here. Your rivers ran all the way to the sea. So these are old river valleys that are now canyons in the ocean because they're covered in ocean water. Hudson River Canyon, they're canyons. And then you have your deep sea fans. That's part of the continental rise, the sediments. So Trenches are tectonic. They're really deep. Canyons are not as deep. They're old river valleys that are now underwater. So canyons are perpendicular to the coastline, whereas trenches are parallel to the coastline because they run along the continental margin. So submarine canyons are features carved into your continental shelves, old erosional features. The continental rises are the sediments that are left over from erosion that have, and you have underwater avalanches and stuff that as sediment falls down and builds up down here. We call that turbidity currents. There is an undersea avalanche and all that sediment is sliding down the slope until it reaches the bottom and piles up. That's called a turbidity current, a underwater avalanche due to erosion. Now in our deep ocean basin, we do have a ridge system. Hydrothermal vents are undersea volcanoes. The abyssal plains and hills are extinct volcanoes that we call seamounts and guyotts. So seamounts and guyotts are the two types of abyssal hills. And then we do have trenches at subduction areas with volcanic island arcs. So there's our oceanic ridge system in red. And in green, that's the subduction zones. That's where the crust is disappearing where it's green and it's being formed where it's red. These are taken from actual measurements, you know, the 10 centimeters, 15 centimeters, 15.7 centimeters. That's how fast they're spreading. So here's your fastest spreading and then slow spreading, 1.5 centimeters. And here's your Caribbean subduction zone where that island arc is. Here's the Aleutian Island subduction. There's Japan. Okay, you have, so these are our subduction zones. These are our ridge system, and that's how fast our ridge system is spreading. So crust is being created at the same rate it's being destroyed. It's being created at oceanic ridges. It's being destroyed at subduction zones. You can see how active the West Coast is, very active margin, because you've got a whole green there. That's active, very active margin. Pacific Island Rim, active. Passive margin, nothing going on in the Atlantic here. Nothing going on. Nothing going on here. So that's your passive margins. These are the transform faults we discovered, talked about them last time. They're fractures in the ocean floor. So you're having your spreading, but they're spreading at different rates. So you're having transform boundaries as well. On the ocean ridges, there's transform boundaries. There's also hydrothermal vents or black smokers because the hydrogen sulfide comes out as black, although it's not smoke. Take a look. Here's chemosynthesis, bacteria growing on them, tube worms. These hydrothermal vents fuel entire deep sea ecosystems with chemosynthetic raw materials. The abyssal plains soundings, look how they're relatively flat and they're somewhere in the neighborhood of 5 or 6 kilometers on average. Notice here are your continental shelves. They're very shallow. And then your slopes dropping down. Also, as far as evidence of plate tectonics, look how this fits right into there. So Here's the soundings from South America to Africa, the Atlantic Ocean. Now, abyssal hills extend outward from the oceanic rift. They're extinct. A guyot has flat top, seamount, rounded top. Remember when I said those currents get pushed up, a deep sea current, and that brings nutrient-rich and oxygen-rich water into shallower regions. So these areas around seamounts and guyots can be very productive, while the deep ocean is not very productive. And occasionally they come up above land from uplift, like St. Matthew Island, the Emperor's Seamount Chain near Hawaii also. So here's some images of seamounts. Guyots, like I said, are flat and top, so they're often home to reefs and a very diverse seamounts and guyots. Our deep ocean trenches occur on subduction areas, and here's the main trenches outlining the subduction zones. They are the deepest and they are parallel to the plate. They're not coming at right angles like those submarine canyons were. And our island arcs, archipelagos occur where we have ocean to ocean subduction causing a shield volcano, which are the largest volcanoes on Earth, the shield volcanoes. The shield volcanoes are basaltic volcanoes. Now, this image is the side-by-side comparison of the features of our continental margins. Passive, wide shelf, deep sea fan, submarine canyon. Here, sediments build up. This is where you get your oil, your gas deposits, natural gas and oil, and these sediment traps. Wide shelf, so you don't get big waves. Here, very narrow shelf, volcanic mountains behind that beach, coastal plain area, trench really near shore. It's being pushed down, so you're not getting the deposits. The deposits are being swept under and melted. So we call the Atlantic and Pacific type margins. Here's your main drainage basins. In the Atlantic, very flat, ocean ridge system. In the Pacific, ring of fire, very narrow, steep drop off. Now the Indian Ocean, here's your subduction, here's your ridge, here's your subduction area. This is where the biggest killer tsunamis originate, because it's so close to hugely populated areas in Indonesia, and it's quite tectonically active. So the Indian Ocean, the smallest ocean, there's the ridge and another ridge system, and then here's your subduction zone. And when there's a tsunami here, hundreds of thousands of people usually perish. It's always a tragedy when this area has earthquakes. All right, folks, that wraps up our lesson today. Right before I dismiss you, I just really would like to, if you'd give me 1 second, I'm hoping to check the syllabus just to see what else is due. What else is due on next Wednesday. I promised it would be the last time I was nagging at you about assignments, but I kind of lied. I just want to double check because I'd hate to not remind you when something was due and then have you rush. Discussion Forum 2 is also due next Wednesday. And I do believe we discussed that last class. It was the deep ocean. So we discussed that, but just your last reminder before I dismiss you, we don't have class Monday. You have 2 things due next Wednesday. Tonight, when you turn your work in, tomorrow I will post all the grades so you can check tomorrow night. The weekend, I can't promise I'm going to check email constantly. If there's an emergency, text me. If not, send me an email and I will address you first thing when I get back to the office. I hope everyone has a fantastic Labor Day. I'll handle any questions you have at this time. If you have no questions, we are dismissed.
I have questions about the quiz 2.
Okay,
We talk about its quiz today? No?
yes, you do quiz, the first quiz today.
No, quiz number 2.
Well, we haven't got to quiz number 2 yet.
Quiz number 1 we did already.
Yeah, it's due today.
We didn't do it. I remember we did already quiz
We
number
went
1.
through the review. We're in our second unit right now.
Yeah, but I did quiz number 1.
Okay, good. Then you don't have to do it tonight.
Ah. Well, may you check once time my name?
Well, I mean, I can't do that now because I'm at the Zoom meeting. I'm not in class and I can't check your submissions right now because we're not on that. Great.
No, yeah, after the class, I have to be sure it's I did it or not, or maybe I something.
Well, I mean, did
online.
you take the quiz?
Yes, I remember it.
Did you click submit?
Yes.
Well, then you did it. I will be posting grades tomorrow after everyone does it.
Yeah, but I want to you check it. I did it. It's exactly what we talk about, or maybe I did something different things. I don't know. I'm not sure.
Well, send me an email and I'll check before I go to see what you've turned in.
Oh, thank you. Thank you.
Okay?
Yeah, thank you.
No problem. No problem at all.
Professor, I didn't see a slide on a thing called table mounts. Where does that
Okay,
fit
I didn't
into the-
include that.
Oh. So that's similar to
Guyot's, very similar to Guyot's.
Gaios.
Yes,
Okay, thanks.
no problem. All right, have a great weekend. I'll check for your email before I go home today, okay? Bye.